Hello, this is Robert, and in this video I would like to discuss creating programs using the different number data types that we have available. So I've set up my program here, and you can see that I've included the IOStream library, and then I have my usual using namespace standard, and then I have two constants set up right there, and we'll discuss why we have those two constants. You can see that I've set up the number of pennies in a quarter, so 25 cents for a quarter. And then I've set up a constant double pi, and I've set pi equal to 3.14. It's customary to set up your constant globals like this using all caps, but you don't have to do that. If you would like to use lowercase for your constants, that's fine. I'm going to follow the standard and make them all uppercase. They're easier to identify as constant globals when they're in all caps like that. The other thing we have at the top of the source code file here are two single line comments. So single line comments use two slashes at the beginning of the comment. Single line comments are good when you want to place a comment on the same line as a statement. So this comment right there is on the same line as this declaration right there. I'm declaring the variable radius. The other style of comment is the multi-line comment. So if I'd like to make this just one comment, what I can do is I can use an asterisk. So slash asterisk or slash star, and then notice that it created, it converted all of my code into a comment because multi-line comments start at a slash star and then they end at a star slash like that. So now I have a multi-line comment right there. Okay, let's take a look at the code that we have. The first section of code, right after my variable declarations right there, this first section of code will calculate the radius, it'll calculate the area and the circumference of a circle. So notice that I have the radius set up, and then I prompt for the radius. So here's the prompt to ask for the radius, and then I use a cin statement to get the radius from the user when they type it on the keyboard. And then I'm calculating the area right there. So area is pi r squared, right? Okay, so radius times radius, that's the radius squared. And then I have times pi right there. And then the circumference is 2 pi r, or 2 times pi times the radius. So I'm calculating the circumference right there. Always use appropriate variable names. Okay, and it's just like that comment says right there. Technically, I could just say r right here, right? But r is a very short variable name, and it may not be obvious to other coders or yourself in a couple of weeks what you're doing. So r isn't a long enough name to describe what you want to store in that variable. So always use appropriate variable names. Circumference is a rather long word, and so if I want to shorten it up a little bit but still know what I'm talking about, maybe circ could stand in for circumference, and that way I don't have to do as much typing, but that's still enough of a variable name that I can tell what it is. C is not appropriate. That's too short. Okay. The other thing about variables in C++ is that they are case sensitive. So for example, if I have circ right here, that's not the same thing as lowercase circ, and so you can see that I have an error right there. The other thing about C++ is that I have to declare my variables before I can use them. So I've declared area and circumference right there. Let's say, for example, that I wanted to calculate the area before I have my variable declaration. So I'm going to cut it from there, and I'm going to place it up here. Well, now I have an error, and if I mouse over it, I can see that the identifier area is undefined because we have our declaration right here. So what we're doing is we're trying to use area before it's declared, and so the compiler will not allow that. You have to have your variables declared before you use them. So I'll place it back to where it was. Okay, another common mistake in C++ for beginners is that you might be tempted to create area and define what it will be when you declare it. For example, I have seen this mistake before. Some coders feel that they can say that the area is equal to the radius times the radius times pi right here. Okay, so if we do that, and then I'll put circumference down on the next line. This is too soon, right? So we've declared radius right there. If we try to figure out what the area is at this point, radius at this point is undefined because we haven't asked the user what the radius is. So this calculation is being done too soon. It's like putting the horse before the cart, right? We won't know what the actual radius is until this statement right here. So we can't calculate the area until after we know the radius. I am calculating the area on this line and the circumference on this line. Remember that C++ programs start at the first statement in main, and then it's called sequential execution. It will move its way down the code. So after all of these variable declarations, it will execute this cout statement, and then it will execute this cin statement, and then we'll know the radius. So then we can calculate the area and the circumference. Up here, it's too soon. Okay, so let's just remove what we have here, because this will cause area to not contain meaningful data. It's also a good idea to initialize your variables. So even though we're going to be calculating area right here, and then we're going to be using it in a cout statement right there, it's always a good idea to initialize your variables. So I'm just going to set it equal to 0.0. It's a good idea to use 0.0 in order to remind yourself that this is a double variable and not an integer. Notice that we have change right here, and I've initialized that to 0 just using the whole number 0. Okay. Then I'll initialize circumference as well, equal to 0.0. All right. So in this code right here, we're asking for the radius, and then we calculate the area based on the radius and the value pi. Let's take a look at why I declared pi as a constant right here. If I had wanted to, I could use the literal value for pi. So I could say 3.14, right? Doing this is not a very good idea, though, because it can lead to errors later on. And there's also another benefit to using the constant pi here as well that I'll discuss in a minute. If I use a literal like this, I might make a mistake. So, for example, I might accidentally type a 5 here, or I might leave off the 4. And so then maybe here I could if I use a literal for pi here, I might say 3.1415 or something like that. So now I have more precision for pi here than I did up here. Okay, and so if I type literals in my code like this, there's the opportunity to make a mistake. And so using literals in your code is not such a good idea when you have something like the value for pi. The other thing that I could have done is I could have created pi here. I could have said double pi, for example, and then if I initialize that to 3.14, that would be the other option. Creating double pi here, though, does not save me from making another mistake. And that could be that I could reassign a value for pi here. So pi equals 2.5, right? There's nothing in the code that would keep me from making a mistake like this. This is kind of a silly example. I mean, I would never set pi equal to 2.5, but there might be times when you accidentally might set a value to something else that you don't want to be changed. And that's what const in front of the variable name allows us to do. Const means that pi cannot be changed. So now that I have constant double pi here, I can't reassign that constant value. So let's say I try to change it to 2.5 again. Now it says that the expression must be a modifiable L value. L values are the values that appear on the left side of the assignment statement. So what we're doing here is we are trying to assign 2.5 to a constant value. And so since I said it was constant, it is a syntax error now. So that will save me from making a simple mistake. Okay, we don't really need this version of pi because it was just for an example. Okay, so once I run this code, I'm going to type in the radius, and then it will calculate the area and the circumference, and then it will do output here. Notice that I have an area and a circumference set aside to store those values. There might be times when you don't necessarily need to store the value. And in that case, if you just want to do output, you can use the expression in your cout statement if you would prefer. So let's say that we don't need to store the circumference. So I'll just comment out that particular code. And now when I run the code, the compiler will think that this is a comment and it will not make it part of the program anymore. So what I could do if I don't need to store the circumference, what I could do is I could just take this expression and I'll copy it with Control-C, and then right there where I'm doing output for circumference, I'll just paste in the expression right there. I need to update this back to pi, so I'll change that back to pi. And now we have the expression here instead. So let's say that we need the calculation for the circumference later on in our code to do another calculation or to do more output of the circumference or whatever the case may be. If ever we need to use this calculation later on or multiple times, it's a good idea to store it in a variable. If we only need to do output of the circumference, then it's perfectly fine to just use the expression instead. Okay, let's go ahead and put back the variable. And then I'll correct this calculation so that it says pi. And then I'll go ahead and do circumference here. Okay, the other thing that the other benefit of using a constant here, and I need pi right there. The other benefit that we get from using a constant when we have something like pi is that we don't have to update every single place that we have pi in our code if we had used a literal. So say for example I wanted to have 2 places of precision right here, so 3.14. And so let's say that I go ahead and use 3.14 right there, and then I have 3.14 right here. Well, suppose that I now need a little bit more precision. If I need more precision and I have this literal sprinkled throughout my code, I have to track down every place that I used it, and I have to update it to the more precision that I want. So 3.14159, for example. So I would have to update it there, and then I would also have to update it here. Okay, so that's kind of a pain, right? Well, by using a constant for pi, I can update it all at the same time just by changing it in this one location right here. So if I compile and run this program now, it will use 3.14 for the values of pi wherever I use pi in my code. So right here and right here. If I update the constant to 3.14159, now it's updated everywhere that I use pi. So if I recompile and run my program, now I have greater precision here and I have greater precision here. I don't have to track down every place that I used pi in order to update it. Okay, so let's go ahead and take a look at the next section of our code. And what I'm doing here is I'm asking how much change you should get back after you make a purchase. So this is just a simple example of getting change back and finding out how many quarters will be in your change. We are doing division here, but we're doing division with integers. So if we do division or multiplication in this example with doubles, then we will get floating point numbers because radius and pi are both doubles. Down here, we're doing integer division. So change is an integer and quarter is an integer as well. So we're dividing an integer by an integer. Let's say that we get 83 cents back in change after a purchase. So 83 cents. If we divide 83 by 25, we're not. You might think to yourself that we would get a number that would have a floating point component or a decimal component. But since we're doing integer division, we're always going to get a whole number when we do division. Let's take a simpler example. Suppose we wanted to know what 7 divided by 4 is, right? Well, the output that we would get is 1, not 1.7 or 1.8 or whatever the case may be, right? Because we're doing integer division. So this is integer division. Remember that if we don't have a decimal point with a literal number like this, that the compiler will interpret that number as an integer. So we have an integer divided by an integer. Suppose we have 4.0. Well, now we have an integer divided by a floating point number. So 7 is an integer and 4 is a floating point number. So now we will get a floating point result. So 7 divided by 4, this is called a mixed expression. And so the 7 will be converted. So implicit coercion is going to happen with the 7. And so that will be converted to a 7.0, and then that's done automatically by the compiler, and that's why it's called implicit. So that's a mixed expression rather than just an integer division. I could also say 7.0 divided by 4.0, and now it is a floating point operation. So floating point operation. All right, so let's go ahead and we will see what we get if we want to know how many quarters we get back in change. And then this operation right here, this is modulo, right? So that will give us the remainder. So this statement will tell us how many quarters we get back when we type in our 83 cents. We should get 3 quarters back, right? And then this will tell us the remainder of the division. So what we're going to do is we're going to take the 83 cents and we're going to use modulo 25, right? So it does the division to get 3, and then it will tell us how many pennies are left over after we get back 3 quarters. Okay, let's go ahead and run this code and see what we get. Okay, so please give me the radius of a circle. How about a radius of 1.5? Okay, so the area of the circle would be 7.06, and then the circumference is 9.42. How much change do I get back? Well, I used 83 cents as my example. And so 25 goes into 83 3 times, so we would get 3 quarters back. And then there would be 8 cents left over. Okay, so this is an example of doing operations with floating point. And notice that we got floating point values. And then when we did integer division and integer modulo, we got integer values sent to the screen. Also notice that I don't have a variable set up, so I'm just using the expression in my output right there and right here. Remember that modulo is not available for floating point numbers. So for example, if I wanted to do cout 1.2 modulo, and that's the percent sign, modulo 3, for example, I have a syntax error right there. So expression must have an integral or unscoped enumeration type. Okay, so basically it has to be an integral. So 1.2 is a floating point number, so I'm not allowed to do modulo right here. Let's change this to a, how about an 8? If we did 8 divided by 3, that would give us 2 as the result. So if we did cout 8 mod 3, we would get 2 for output. Okay, so I hope this has been useful and has allowed you to understand how we might use the different number data types, doubles and integers, and why we set up constants. Okay, thanks.